Hello everyone, welcome back to the course of software engineering. This video is brought to you by Newton's group of institutions in association with Redefined Solutions. This is Yegireddy from the Department of Computer Science and Engineering. In this video, we will discuss about some of the other Agile process models. So coming to this particular video, we discuss about other Agile process models. We know that other agile process models have been proposed and are used across the industry. So in today's video, we discuss some common agile process models: adaptive software development (ASD), Scrum, dynamic system development methods (DSDM), Crystal, future drive development (FDD), lean software development (LSD), agile modeling, agile uniform process (AUT). Coming to the first one, that is adaptive software development (ASD). Here, adaptive software development (ASD) has been proposed by Jim Highsmith as a technique for building the complex software and systems. The philosophical underpinnings of the ASD focus on human collaboration and team self-organization. So here, Highsmith argues that the Agile adaptive development approach based on collaboration is as much as a source of order in our complex interactions as a discipline and engineering. He defines an ASD life cycle that incorporates three phases: speculation, collaboration, and learning. During speculation, the project is initiated and adaptive life cycle planning is conducted. So here, adaptive cycle planning uses project iteration information, the customer mission statements, project constraints, that is delivery dates or user descriptions, and basic requirements to define the set of release cycles that will be required for the project. Here, motivated people, they are collaborated in a way that multiplies their talent and creative output beyond their absolute numbers. So this approach is a recurring theme in all agile methods, but collaboration is not so easy. So it encompasses communication and teamwork, but it also emphasizes individualism because individual creativity plays an important role in collaborative thinking. It is above all a matter of truth, or it can be say that we can say that it is a matter of trust. Here people working together must trust one another, to criticize without a hatred, assist without resentment, work as hard as or harder than they do, have the skill set to contribute to the work at hard, and communicate problems or concerns in a way that leads to an effective action. As member of an ASD team, being to develop the components that are part of the adaptive cycle, the emphasis is on learning as much as it is on progress towards the completed cycle. So here, ASD team learn in three ways. One is by focusing group of feedbacks, formal technical reviews, and project postmortems. Coming to the second one, that is Scrum. Scrum is an agile software development method that was conceived by Jeff Sutherland and his development team in the early 1990s. Here the Scrum principles are consistent with the Agile Manifesto and are used to guide the development activities within a process that incorporates the following framework activities, that is requirements, analysis, design, evaluation, and delivery. So here, within each framework activity, work task occurs within a process pattern called as a script. So here, the work conducted within the script is adapted to the problem at the hand and is defined and often modified in real time by the Scrum team. So here, The overall flow of the Scrum process is illustrated in the following figure. So here coming to Scrum, Scrum emphasizes the use of set of software process patterns that have proven effective for the project with the tight timelines and changing requirements and business criticality. So each of these process patterns defines the set of development actions. The first one is backlog. So here a prioritized list of project requirements or features that provide the business value for the customer. So here the items can be added to the backlog at any time, and the product manager assesses the backlog and updates the priorities as required. And the second one is sprints, which consists of work units that are required to achieve a requirement defined in the backlog that must fit into a predefined time box, which is typically 30 days, what we have seen in the previous image. So here the changes backlog work items are not introduced during the sprint. Hence the sprint allows the team members to work in short term but in a stable environment. Here coming to the Scrum meetings, which are short and which are typically 15 minutes. So the meetings held daily by the Scrum team, three key questions are being asked and answered by all the team members. That is, what did you do since the last team meeting? What obstacles are you encountering? And what do you plan to accommodate by the next team meeting? So here the team leader is called as Scrum Master, who leads the meeting and assesses the response from each person. The Scrum meeting helps the team to uncover the potential problems as early as possible. And also, these daily meetings leads to the knowledge socialization. Now coming to fourth one, that is demos, which deliver the software increments to the customers so that the functionalities that has been implemented can be demonstrated and can be evaluated by the customer. So it is important to note that the demo may not contain all planned functionalities, but rather those functions that can be delivered within the time box that was being established. Now coming to the third one, that is a third agile method, that is a dynamic system development method, DSDM. So here the dynamic system development method, DSDM, is an agile software development approach that provides a framework for building and maintaining the systems which meet tight time constraints through the use of incremental prototyping in a controlled project environment. So the DSDM philosophy is borrowed from a modified version of the Pareto principle, which is 80% of an application that can be delivered in 20% of the time. So here it would take a delivery to complete 100% application. So DSDM is an iterative software process in which each iteration follows that 80% rule. That is, only enough work is required for each increment to facilitate the movement to the next increment. And the remaining details can be completed later when more business requirements are known or changes have been requested and accommodated. The DSDM life cycle that defines the three different iterative cycles preceded by the two additional life cycle activities. First one is the feasibility study. So here the feasibility study establishes the basic business requirements and constraints associated with the application to be built, and then assess whether the application is a viable candidate for the DSDM process or not. And the second one is business study. So this establishes the functional and informal requirements that will allow the application to provide the business value and also defines the basic application architecture and defines the maintainability requirements for the application. And the third one is functional model iteration, which produces a set of incremental prototypes and that demonstrate the functionality for the customer. Now, coming to the fourth one, that is a design and build iteration. So here, this revisits the prototype built during the functional model iteration to ensure that each has been engineered in a manner that will enable to provide the operational business values for the end user. So in some cases, these functional model iteration and design and build iteration occurs concurrently. And the next one is implementation, which places the latest software increment into the operational environment. And it should be noted that the increment may not be 100% complete, or changes may be requested as the increment is put into the place. In either cases, DSDM development work continues by returning to the functional model iterative activity. Now coming to the fourth, that is crystal. So here, Alistair Cockburn and Jim Highsmith, they created the crystal family of agile method in order to achieve the software development approach that puts a premium or maneuverability. So here, during what Cockburn characterized as a resource limited cooperative game of invention and communication, with the primary goal of delivering useful workflows or working software, and a second goal of setting up for the next game. So here, the crystal family is actually the set of examples of the agile process that have been proven effective for different types of projects. Here the intent is to allow agile teams to select the members of the crystal family that is most appropriate for the project and the environment. Now coming to the fifth one, that is future driven development, FDD. So here, future driven development, FDT, was originally conceived by the Peter Cod and his colleagues as a practical process model for object oriented software engineering. Stephen Palmer and John Flessing have extended and improved the Cod's work, describing an adaptive agile process that can be applied to moderate sized and large software projects. So here, like other agile approaches, FDD adopts the philosophy that emphasizes the collaboration among the people on an FDD team and manages problems and projects complexity using future-based decomposition, followed by the integration of the software increments and communication of technical dealings using verbal, graphical, and text-based means. So here, FDD emphasizes software quality assurance activities by encouraging an incremental development strategies. So here the use of the design and code inspections, the application of the software quality assurance audits, the collection of metrics and use of patterns for analysis, design and construction. So here, in the context of FDD, a future is a client valued function that can be implemented in 2 weeks or less. So here the emphasis on the definition of future provides the following benefits. Because futures are small blocks of deliverable functionality, users can describe them more easily and understand how they relate to one another more readily and better review them for ambiguity, error or omissions. And these features can be organized into the hierarchical business related grouping. Since the feature is the FDD deliverable software increment, the team develops operational features every 2 weeks. Because these features are small, Their design and code representations are easier to inspect effectively, and the project planning, scheduling, and tracking are driven by the feature hierarchy rather than an arbitrary adopting software engineering task set. So here, Cod and his colleagues suggested the following template for defining the features. Action, the result, by, for, to, an object, where an object is a person, place, or thing. So here, FDD provides the greater emphasis on the project management guidelines and techniques that many other agile methods do. So here, FDD defines 6 milestones during the design and implementation of the future. One is design walkthroughs, design, design inspection, code, code inspection, promote to build. Coming to the sixth one, that is learn software development, LSD. Learn software development, LSD has adapted the principles of lean manufacturing to the world of software engineering. The lean principles that inspire the LSD process can be summarized as eliminate waste, build quality in, create knowledge, defer commitment, deliver fast, respect people, and optimize the whole. And each of these principles can be adapted to the software process. And coming to the seventh one, that is Agile modeling. Agile modeling, AM, is a practice-based methodology for effective modeling and documentation of the software-based systems. Simply put, Agile modeling, AM, is a collection of values, principles, and practices for the modeling software that can be applied on the software development project in an effective and lightweight manner. So here, the agile models are more effective than the traditional models because they are just barely good and they don't have to be perfect. So here the agile modeling adopts all the values that are consistent within the agile manifesto. The agile modeling philosophy recognizes that an agile team must have the courage to make the decisions that may cause it to reject a design and refactor. So here the team must also have the humility to recognize that the technologists do not have all the answers and that the business experts and other stakeholders should be respected and embraced. So here, the agile modeling suggests a wide array of code and supplementary modeling principles, those that make agile modeling unique. The first one is model with a purpose. Here, a developer who uses the agile model should have a specific goal in mind before creating that particular model. Once the goal of the model is identified, the type of notation to be used and level of detail requirement will be more obvious. And the second one is use multiple models. There are many different models and notations that can be used to describe the software. Only a small subset is essential for most projects. Agile modeling suggests that to provide needed insight, each model should present a different aspect of the system, and only those models that provide the value to their intended audiences should be used. And the third one is travel light. As software engineers work proceeds, keep only those models that will provide a long-term value and jettison to the rest. So every work that product that is kept must be maintained as changes occur. This represents work that slows the team down. So Ambler notes that every time when you decide to keep a model, you trade off the agility for the convenience of the having that information available to your team in an abstract manner. And the fourth one is content is more important than representation. So here modeling should impart information to its intended audience. A systematically perfect model that imparts little useful content is not as valuable as the model with flawed notations that nevertheless provide valuable contents for its audience. And the fifth one, know the models and the tools you see to create them. So here we need to understand the strengths and the weaknesses of each model and the tools that are being used to create it. And the last one, that is sixth one, is adapt locally. So the modeling approach should be adapted to the needs of the agile team. Now coming to the eighth one, that is agile unified process, AUP. So here the agile unified process, AUP, adopts a serial in the large and iterative in the small philosophy for building the computer based systems. Now, by adopting the classical UP phased activities, inspection, elaboration, construction, and transition, Agile unified process provides a serial overlay that enables the team to visualize the overall process flow for a software project. So, however, within each of these activities, the team iterates to achieve the agility and to deliver the meaningful software increments to the end users as rapidly as possible. So here, each AUP iteration addresses the following activities. First one is modeling. So here the UML representations of the business and the problem domains are created. Implementation models are translated into source code. In the testing, link XP, the team design and the execution, that the series of tests to uncover the errors and ensure that the source code meets its requirement. And fourth one is development. So here, like the generic process activity development, in this context, which focuses on the delivery of the software increments and the acquisition of the feedback from the end users. And fifth one is configuration and project management. So in the context of AUP, configuration management addresses the change management, risk management, and the control of any persistent work products that are produced by the team. So here the project management tracks and controls the progress of the team and coordination team activities. And the sixth one is environment management. So environment management coordinates the process infrastructure, which includes standards, tools, and other supported technologies available to the team. So these are the other different agile process models what we are commonly using. Thank you. That's it for now. Thank you all. If you like this video, please subscribe to my channel and press the bell icon for the latest notifications. Thank you all.